Today, I'm welcoming Tony Coates, who is taking over from Les, who presented the first episode 1 of The Hazards of Pits 4 weeks ago. Those of you that did listen or watch that episode, you'll have seen those. We're looking at the biological hazards. Those are quite surprising and quite shocking, really. You need to be careful, and you certainly need to be aware of what's going on in those pits. You can't take it for granted. There's kind of an unseen, as generally unnoticed occupational hazard, but they are definitely a hazard, and it's just as well to be aware of what's lurking there. If you weren't scared enough by what you were told in the last episode, where Les was, I'm not sure whether his enthusiasm for our impending doom was always quite appropriate, but he was certainly very enthusiastic in his delivery, telling us of what is lurking beneath that pit lid. Tony is going to tell us about the electrical and other hazards that could get us if we're not careful. Very important topic, and to support us in that, I'd like to thank always Felicity and Damon, who do so much work behind the scenes to put this all together. And of course, our very expert panel of Seward Ford, who's joining us from where did you say it was? St. Peters, is it? You're down in Florida, so living the dream. Expert in airfield lighting. Similarly, Carl Johnson, an expert, will be delivering our next webinar, the runaway train. More of that later. But also sunning himself in Florida. Tony Smith, of course, very honoured to have you. Venture Papian, creator of so many of the standards that we live and die by. So Tony is joining us from I'm not so sure quite as hot England, but anyway, so thank you very much again for your time, Tony. And so, without any further ado, can I hand over, Tony, if you could launch the presentation, and you could take it away, please. I just have to do a bit of admin there. Good. Hopefully we can now launch the presentation, and we'll soon see episode 2 of The Hazards of Pits. So thank you, Tony. Over to you.
Right. Hopefully you can hear me.
We can.
So we're on to Aerodrome Pit Hazards Part 2. I've lost control of my slides. It's handy. We have a slight technical hitch. I cannot change the slides.
Have you tried using? That's it.
Right. So, as Robert already introduced the people who are here, so we'll look at welcome to episode 2 of Aerodrome Pit Hazards. Now, Hidden Hazards of AGL Pits was presented last month, as Robert said, by Les Payne, a former colleague and a good friend of mine, and he went into the side of things that you don't see and definitely don't generally think about, which is the microbiological side of things. And that what I would say at this point is it's available to watch on tmstraining.aero. It's well worth the watch. It will certainly get you thinking about things that you haven't thought of previously. But following on from that, we go into episode 2, and it may seem quite a mundane sort of subject, but it's something that every airfield technician comes across at some time in their working life, and that's working in or near a pit. Now, when they're laid in, everything's nice and straightforward, and it looks nice and neat. But when we start work at an airfield, normally the infrastructure is already there. It's an existing airfield. And so we look at it at the beginning. How many pits do we actually have? I think if you do the count of your pits, you'd be surprised how many. At the small airfield I used to work at, Cap 1, there were 78 pits there, and you wouldn't have thought it. But the next question is, where are they? Now, realistically, every single aerodrome has the requirement and the responsibility to maintain and keep up-to-date records and plans of the electrical layout and circuitry of the airfield. It must be maintained up to date, and it should detail all cable runs and pits, and depending on how detailed it is, the fittings. Now, this can either be on plans, or to a certain extent, you can integrate it into an asset management system and have it so that you can then open it up, not only saying the location of the pit, but what there is in it. And this is something that we'll come on to further in. So can we access them? That's the thing. We've now found that we've got 150 pits on the airfield, and we know where they are, but can we access them? Now, the ideal situation is you can get your permissions from air traffic control and get everything booked up and ready, and you can go along and you can open up the pit and you can work quite happily. If everything was like that, it'd be a wonderful life that we live. But unfortunately, sometimes access can be a bit difficult. In fact, sometimes pits can actually go missing. And if you look at the edge of this pit was actually under a foot of soil and was eventually found. So, you know, access to that was totally impossible to start with. This one, it's a small pit. It's on a taxiway, so we've got a restricted access. We may be able to close down the taxiway for a period of time so we can do whatever's necessary, or it may be we've got to wait until the airport is closed. This one, definitely, we'd have to wait until the airport is closed. It's on the actual runway. So therefore, you know, I shouldn't think air traffic control would be too happy if we said, well, can we have 30 minutes out on the runway in the middle of the busy season? So we now know where they are and what access we've got, but do we know what's in them? As I said in the last bit, we could actually create, as part of an existing asset management system, be it electronic or manual paperwork, we can actually list what's in there. But in order to look and see, hopefully when you lift the lid, this isn't what you see. You like to see something like the one on the right, so you know what's in there, all nicely labeled up, plenty of spare cables, so you can get to things easily. And normally you'll find that it's somewhere between the two. The last thing you want to find is when you lift the pit lid, you've got undergrowth actually growing in the pit. It's not particularly good. It's not a nice way to be. So what is in them? To find out, we must raise the lid. Now, at this point, I'm going to highlight the fact that the requirement for any work with pits to start with is there has to be a full risk assessment carried out in order to ascertain the potential dangers and hazards of just working in the pit. Now, if you take last month's webinar and incorporate it with this one, you'll suddenly realize that working in a pit is not the mundane thing that people sort of say, oh yes, and by the way, you'll be every now and again you'll be lifting the pit lids and you'll be changing transformers. It's actually quite a hazardous operation. And the purpose of these webinars, the last one and this one, is to actually get you thinking about what you're doing, your safety, your employees' safety. What do we need to do? Are there things we need to put in place? And that's the whole thing about this. It's to get you thinking about a role which has actually been deemed as almost secondary to maintaining the lights and making sure that the runway is nice and clear and bright and everything. So it's a very, very important and potentially dangerous role that you work when you're working in the pits. So we've got different types of pit lids. Straight lift pit lid. Generally, you have metal keys that you put in, turn, and you just lift the pit lid off. And then it's moved to one side. Lift and drag. You can just see one in the top right-hand corner. You have two large lever type bars that fit into the lids. You turn them and lock them in place, and then two people. And I must sort of emphasize the point that when lifting lids, you should always have two people. The two people then lift the end and drag them towards the direction that they're in, and it pulls it across the runners that you see on the edge of the pit. Now, one of the things at this point I'll say is that those runners get bits of dirt and that in them. Whenever you lift the pit lid, take that opportunity to clean not only the runners and the edges of the pit, but also the edges of the lid as well. So the third type is a hinged lid, generally constructed in sections. Quite often they're in triangular sections, and each section is able to be raised. Depending on what type of pit you've got, the actual sections can then be removed individually in order to, again, ease the access into the pit. It's quite interesting speaking with Carl just before the webinar started. He was saying that the FAA requirement is that with hinged lids, they have to have a bolt down capability because of jet wash. So again, if you do have hinged lids on pits, think about where they are, think about what effect different things have on it. And then the last type I'll mention here is the hydraulic. They're similar to a hinged, however, they have hydraulic rams which make it nice and easy for the lids to come up. Again, they need to be cleaned, they need to be maintained, they need to be lubricated. But the thing people forget about are the hydraulic rams need to be tested and checked on an annual basis. The last thing you want if you're leaning in a pit is the hydraulic ram to fail. And if you think, well, that sort of thing doesn't happen, if you think of a hatchback car where they have the hydraulic rams on the tailgate, I've seen quite a few of those in my time where somebody has to hold the tailgate open because the hydraulic ram has failed. They do fail. They do need to be checked. They do need to be almost, for want of a better phrase, calibrated to make sure they're working correctly. The raised sections, again, can be often disconnected, which allows ease of access into the pit. But to make life easier for us, pit lids are heavy and lifting aids are available. And for every type of pit lid, there is a lifting aid available. But on top of that, because of the weight of the lids, in the UK and Europe, they come under the manual lifting and handling requirements in the UK under the HSE. So therefore, personnel need to be fully and properly trained in manual handling techniques. So that is something that, again, needs to be thought of and taken into consideration. The other thing about it is that manual handling technique certificate, depending on which regulatory body you have and also your insurance company, may last anywhere between 1 and 3 years. A lot of insurance companies are saying they have to be refreshed every 12 months. If you look at the ICAO requirements of training, you're looking at once every 3 years. The other thing is that the lids need regular inspection and maintenance. Inspection, visual inspection, looking for damage, ensuring the lid is correctly seated. As I said, it was highlighted to me before we started this webinar, that in under FAA regulations, hinged lids need to have a bolt down capability. The thing is, you need to make sure that every lid is seated correctly. It's rather like if you go back a few webinars, we did one on torquing. It's rather like if you have the incorrect torque setting on a fitting, it's liable to come loose. Well, if the pit lid is not seated correctly, it may not actually fly out of the way, but it could move slightly, which would create a weakness for anything going over it. So you look for damage, cracking in the casting. The majority of them are cast, so therefore they are vulnerable to cracking. So look for the damage. Physical maintenance. Maintenance should be raised, and depending on type, seating should be cleaned and where appropriate lubricated. I showed the picture of the lift and drag type. It has runners. What I will say with that is do not put any form of lubricant in those runners, because what happens is any bits of dirt or soil that naturally move around fall in there, and it makes a conglomerate, a congealment of materials, which makes it very, very difficult to remove that lid. It almost creates a vacuum effect, which makes it difficult to almost break the seal to get the thing open. What you can do is you can spray it with, I'll use a trade name here in the UK, spray it with something like, having cleaned it, spray it with something like WD-40, but make sure you clean not only the runners, but also the pit lid itself. With regard to hinged lids, the manufacturers will recommend the type of lubricant. If it's an old hinged lid and you don't know who the manufacturer was, then use a light lubricating oil, not a heavy one, a light one. And anything you do with regard to the maintenance, you need to maintain records. You need to keep records. And one last thing. Over the years, we've created larger aircraft. A lot of the initial infrastructure of airports was done many years ago, prior to the A380, perhaps prior to the 747. And so, is the pit lid you've got capable of taking the weight of modern day aircraft? You know, what does the manufacturer say? These photographs, courtesy of Boeing, show an aircraft. All right, it's moved off the runway slightly and went onto the soft, but just in the soft was a pit which had a concrete lid on it, which at the time the airport was created and done first was perfectly adequate for the weight of aircraft. However, this aircraft went over it, the pit lid collapsed, and it ripped the undercarriage off the aircraft. So there's a thought is if you've got the larger aircraft now landing at your airfield, what's the weight? What weight are your pit lids manufactured for? The manufacturers can give you the recommendations with regard to weights. So, my friend Les, hazards part 1. What lurks beneath the lid? The ideal situation, something like this. You've got all the component parts easily accessible. You've got plenty of spare cables, so you can lift the component part out of the pit, and you can work without having to lean into the pit. That's the ideal situation. Unfortunately, several technicians, including myself, have come across a situation similar to this, where you look at it and you think, where am I going to start with this? I've got to find a certain transformer. I've got to find a primary cable. Where are you going to start? Normally, when you first get on, it's somewhere between the two, and slowly over a period of time, you increase the efficiency of the pit. And then, as we've seen previously, you might actually find something like this. Now, there are certain airports, which I think we all know, where they have tidal pits, where the pits are full of water when the tide comes in, because of the water plane under the ground. I know certainly I've worked at one of them, and it's quite interesting where when it's high tide, you can't open the pit at the end of the runway. When it's low tide, you can. So how are we going to retrieve the cables from in the water? Deadly silence. The recommendation is actually to pump the water out of the pit, which is a great idea if you can do it. Unfortunately, very few aerodromes are actually horizontal. And definitely, when it comes to pit and duct, they're not horizontal. And so you'll find that if you've got one pit full, the next pit up the chain will be 2/3 full, The next one up will be a third full. And so slowly you're pumping out the entire airfield. So you should be able to pump the water out to a safe depth, I'll put it that way, although there's nothing really safe about any water in a pit. So you then have to hook the cables out of the pit. Please be aware that any hooks you use, because of the fact you're looking at primary cables, should have a rating of a minimum of 5 kV, 5,000 volts, with regard to insulation. You know, that is potentially what your maximum could be. So therefore, they have to be rated at least at that level. A little anecdote here. I was at an airfield the one time where they had quite happily showing off the new hooks they had made specially for them. They were absolutely superb, beautiful things, nice handles, well made, ergonomic, you could hold them nicely. The only problem was they were made out of stainless steel, which if you've got primary cables going through a pit, may not be the best of things to have. Or you could lift the cable using your hand. Now, speaking as an airfield technician, I doubt if there are many people watching this who have worked as airfield technicians who have not at some time lifted a cable out with their hand. Realistically, it is not a good thing to do. The dangers, straight off, allergic reaction. It may be to a deposit that's on the cable if it's dry. It may be to something in the water and the moisture if it's wet. You know, because you've got electricity, because you've got all sorts of weird and wonderful chemicals, you get a certain seepage of jet fuels and things like that. There's always a mixture of chemicals in the water in pits. And if you've got a slight bit of electrical leakage, then you start creating a reaction in there. So you may get an allergic reaction. You could get bacterial or viral infection, just to cheer you up. And if you get, again, think of the last one, where there's the last seminar where this was brought up, please remember that if you don't change out of your work clothes, when you go home, that viral and bacterial infection is potentially on you. And you could give it to your kids, to your wife, your partner, whoever. Yeah. So please be aware of that. And the last one, which is the one we all expect, electric shock. Now, the two things that keep us safe in a pit from the electrical situation there is the first one is the insulation resistance of the circuits. A high insulation resistance means that there is very little chance of you getting electric shock from the current that is going through the cables. The second one is having a zero earth leakage situation. Because if you've got a moist pit and you've got cables running through it, you want to change the transformer on circuit 1, and you've got circuits 3, 4, and 5 running through the pit as well. So you isolate circuit 1, but circuit 4 has got earth leakage. It's only got one earth fault, and because one earth fault doesn't adversely affect the efficiency of the light levels, you haven't done anything about it. Unfortunately, that earth fault is actually in the pit you're going to be working in. And so you put your hand in to grab the cable, it brushes against where the earth fault is, and lo and behold, you've become the earth fault for circuit 4. Wherever possible, it is recommended that all cables running through the pit should be isolated prior to work commencing. That's the ideal situation. It's not always possible, but that is the ideal situation. And then some pits are deep. And it's natural if you look at the photograph here that you would automatically think, I need to be trained in confined space working in order to go down this pit. And realistically, you do need that. But the situation now from some regulatory bodies is that if you lean into an opening more than 300 millimeters, that's deemed as being working in a confined space. So this, if you're having a contractor in there doing a rewire, one of the things I'd recommend at this point is ask them to put in a loop of cable in the pits at every joint so that you can hook whatever it is out and you can bring it out of the pit. You don't have to lean in. Again, the majority of technicians will, if they're honest, admit that at some time or other, they've been half leaning in a pit, trying to do a primary joint on a cable, which they can't get any higher up than halfway up that pit. In order to do that, apart from it being very, very dangerous and, and difficult, you should be trained in working in confined spaces. Now, I know that there's a couple of things that have come up, which Carl has said there are differences with regard to the FAA. And when I get to the end of my little chat, I'll ask him if he could fill in the differences that he highlighted to me earlier. Last thing I'll go into at this point, at this stage, is the risk of fire. Unfortunately, moisture, electricity, arcing, it's quite a lethal combination. And you've also got the situation where in some pits, because of the nature of the layout, you've got control wiring adjacent to primary wiring, adjacent to secondary wiring. So you've got a range and a mixture of voltages and currents. So, a slight bit of chafing on a cable, maybe owing to rodents in there, and you could potentially have problems. Now, if you are approaching a pit and there is smoke coming out of it, the ideal situation, first off, apart from notifying the fire service on the airport or the aerodrome, is to isolate every circuit going through the pit. And this again means that you need to know what's running through there. You need to know the layout. The unfortunate thing about it is that because of interleave circuits, because of multiple B centers on an airport, it could be that you're running between 3 or 4 locations, isolating circuits all over the place, which is impractical, especially if you're working with a 2-man crew. So the situation is, if the fire service are available, you need them present. The least that you need is to have in your vehicle a fire extinguisher that is capable of being used on electrical fires. Because as soon as you lift that lid partially, you get the inrush of oxygen with the air, and you will get a flare up. You'll get a flame come up. So you need to be aware of that. Ideally, if you've got smoke, don't move the lid until the fire service arrive there. If you don't have the option, you need to have a fire extinguisher with you that you can use on it. Fires in pits tend to happen, I shan't say on a regular basis, but more often than people care to admit. Because what happens when you have a fire in a pit, it's suddenly all hands on deck to repair and get working and operational whatever part of the aerodrome is that has been affected. So generally, a fire in a pit, assuming you've got adequate spares and adequate cable, jointing kits, plug sockets, whatever, fires in pits are generally rectified so that the aerodrome is operational very, very quickly. So, and realistically, if I look at this webinar session and I look at the last one, there's not enough time in 2 webinars to detail all the potential hazards of aerodrome pits. I've literally scraped the surface on some of the things here. And Les scraped the surface on his. But the purpose of the webinars is to highlight up that working in pits is not just part of the job. And it's to try and stimulate people to think about it. Look at the procedures that you have adopted or you need to adopt. Think of your safety. Think of the safety of your employees. Just lifting a pit lid, there are more man hours lost worldwide from work, from back injuries, than any other cause. You know, there's a duty of care for employees. The employee has a duty of care for himself. And at the end of the day, you know, if these webinars just get you thinking about things, they've done their job. And realistically, there are specific and additional training available on aerodrome pit maintenance. You know, Les, I know, has been involved with myself with regard to writing a full course on them. So there is training available worldwide on pit maintenance. But the main thing to do is just please think safe. And at this point, funnily enough, he's also going to be our presenter next in the next webinar with the runaway train. But at this point, what I'll do, if I may, is I'll hand over to Carl to highlight up some of the differences that there are with regard to the FAA requirements.
Good morning or good afternoon. In the States, we still have a lot of manholes that require confined space entry. But as we're doing work at airports, we try to eliminate those confined spaces by using what we call a can plaza, which is basically a grouping of deep cans to house the circuit cables, make them accessible. And these can plazas replace the manholes. You can get to the cables, transformers, whatever the case may be, at the surface without having to enter them. So while we still have a lot of the old pits, like Tony was talking about, that we have to work with or work in, as we do work at airports, we try to replace them with the can plazas and make them a little more accessible, easier for maintenance to do their jobs.
Just looking at the
Thank you for that interlude, Carl. It's very important to remember we have all kinds of environments and different national practices and regulations inherent in what we do. But we try to bring you the general principles here. Obviously, you need to look to your local regulatory environments and building controls and etc. when it comes to staying legal on these matters. Back to you, Tony.
to me.
Yeah. We've just to jump back one slide. Don't put it up. As Tony says, Carl is presenting in our next webinar on the subject on the subject of railroads, or so you might think from the title. His presentation is the runaway train, which I've asked him to present following its award-winning launch at the most recent IES Annual Lighting Conference in North America, the largest annual lighting conference there is worldwide. And so, Carl, if you could just give us a brief taster, whet our audience's appetite, please.
All right. Well, the presentation will be hopefully an entertaining look at how to create an electrically safe work condition. An FPA 70E, which is the standard we use here in the States for electrical safety in workplaces. Step 6 addresses how to create a lockout tagout. And before you go, oh no, not another lockout tagout presentation, I'd just like to ask you to listen and learn why we're on this runaway train with creating electrically safe work condition. I hope you heard that. Yeah.
I heard you all right, Carl.
Yep. So that's the preview for it, and we'll get some information to Damon to get on the website to allow people to see it.
Good. Well, thank you, Carl. I really appreciate your effort in putting this together. You do, in keeping with the rest of the team presenters here, you do an awful lot of your own free will because your passion is promoting safety and efficiency in the airfield lighting environment, and it really is appreciated. And I get that feedback wherever I travel. So Great. Right now, to panel to work. We're going to now just talk a bit about answer the questions that have come up from the audience. As ever, we have a Q&A box on the on your webinar screen, and if you have any questions, if you could just post them on there, and the team and I will do our best to address them. First is more of a statement. In fact, there's some advice. This is the first 2 points are from Barry White, who's just makes the point that manhole lids you need to lift and slide them, and they need greasing to maintain the waterproofing. And so it's just a bit of advice there. So you just need to keep these. You need to do maintenance on your pits. They're not just there to be left until a disaster happens. I think that's a fair comment, Tony. Would you say?
Well, I'm just actually typing out an answer direct to Barry. The thing about it is, yes. How can I put it? It is said that the slides should be greased in order to assist with waterproofing. The thing is that you have a pit lid that fits into a location. That pit lid is not IP rated anyway with regard to waterproofing. You will get water ingress around the edges of the pit lid. Realistically, the grease in the runners is only there on drag and slides, in theory, to assist the drag operation, because the waterproofing, you can't apply grease around the entire thing, especially as the majority of pit lift and drag pits are two lids, which would just meet in the middle, and it's just literally a contact meeting. So the thing about it is, lift and drag pit lids are not waterproof anyway. The tendency is that if they are greased, they are over greased, and it is actually better to have no grease at all in there than have it over greased, because once you over grease it, all the little bits of soil, dirt, sand, muck and whatever that go down actually congeal with that grease in the runner, and it creates then almost a vacuum seal around the pit lid and the runner itself, which means it is quite a difficult thing to get out. I will not disagree with what Barry says. However, what I will say from personal experience, I would prefer to have a dry runner than grease them.
Okay, thank you for that, Tony. Also, Barry makes the point that that it's always good to have building information modeling systems, something to actually give you the information to tell you exactly what's there. As part of an asset management tool, therefore, and so if you can,
yes,
if you have records.
As we discussed earlier, Robert, electronic asset management systems are available that you can add this onto. But yes, I'm still a firm believer, and the requirement is, if you look at the regulatory requirement, that an aerodrome has to maintain an up-to-date drawing and diagram. With regard to ease of operation for a technician, it's a lot easier for him to go to an electronic asset management system, get the tablet up and say, right, what's in pit such and such, and know exactly what the transformers are in there. Then get out the drawing, find the pit on the drawing, get the reference numbers, so you're cross-referring against the key and doing it that way. You need, ideally, both. One for the requirements of the regulations, which is an up-to-date and maintained drawing, and the other for the ease of operation, ideally an electronic asset management system.
Yeah. So as you say there, it's actually a requirement that you do have the asset management information, and clearly operating an aerodrome. When you absolutely need to know what's there and what to do about it, there needs to be a plan, and that plan needs to include the detailed record showing what's in there, what it's connected to, and and what to do about it in the event of any unforeseen accident, whether that be a fire or anything else that might occur. You mentioned adequate spares, Tony, in your presentation. Now, there's $1 million question. Can you give us a list, please?
Certainly, if the person would care to send a full list through of what fittings he's got, what transformers are operating them, how many he's got of each, along with a blank check signed, I will provide him with the necessary information. Realistically, I think we all know what we would like to keep as spares on an airfield. If you look at the critical areas of lighting, you need to have adequate spares to, in the case of emergency, at least get your one circuit of an interleave circuit of 2 operational again. That's what you've got to look at, because that way at least you then retain the pattern. You can put in an OTAM and say, for argument's sake, 27 approach, bars such and bars 3, 4, and 5, interleave pattern only. So, but you need to have it so that you can, you've got adequate spares to get things back up to an operational standard in an adverse situation, a critical situation.
And clearly, as we know, I think we all experience in our world, if you don't have those spares, getting them quickly can be a real issue. In particular, there's the issue with cabling we discussed earlier. Perhaps you could expand a bit more on that.
With regard to what, Robert?
Available cable.
Yes, primary cable is a wonderful beast. It comes in normally either 500-meter drums or 1-kilometer drums. You need to have adequate cable. If you think about it, if you're on pit and duct, and you had, for example, a fire in a pit, then realistically, the majority of that cable in that pit would not be usable. Now, because you're in pit and duct, you cannot therefore dig up the cable that feeds that area and then joint it. You have to go back to the previous pit. So therefore, you're running quite long lengths of new cable. Just having sort of a couple of 100 meters of primary cable as available is not, in my opinion, adequate spares. A minimum I would suggest would be having a 500-meter drum available on a large airfield, because at least then you've got a fighting chance of getting, as we said earlier, getting back to the situation where you could have your minimum requirement for interleave circuits operational. So you retain, because at the end of the day, if you have a critical situation, it will take time to get things sorted and back. So the first thing you do is you establish the correct pattern of lighting, so that at least you can then say, right, we can go operational, but obviously the pilot makes a decision if he wants to land or not, because you put out a NOTAM. So that's the situation there. So you look at it that way.
Right. Thank you. And there's comments here around the water and trying to prevent water getting in there. Anthony,
yes, I'm just actually looking with regard to Barry. What I'd like is if Barry could drop an email through to TMS Training, t.coates@tmstraining.aero. I'd like to, how can I put it, have a conversation with him, because he's got some information available to him that I'd like to be aware of. So
yes, for the audience there, just to let you know that Barry's suggesting some slide and lift covers that are waterproof, and that's something that if we get that information, happy to share it. We've had a lot of discussion in preparing for this webinar about the potential to drain pits and the like. It's a very complex subject. It will vary according to. There's no magic answer, I'm afraid. It's clear because if your water is coming from the Atlantic Ocean, as we were discussing before today's call, draining the Atlantic Ocean, which is of course possible, is probably not going to be very practicable. But it's an amusing thought. But of course, we should always try to mitigate the risks and the dangers to people. And we cannot, to the point that's been made here, we cannot advocate ever working in situations which are inherently dangerous, where you're not able to isolate all the circuits that are in there, whether that's practicable or not. We should make sure that as part of our risk management plans that we have detailed recovery plans. We should train people. We should have adequate mapping, spare parts. There should be detailed inventories of what's in these pits. We should know exactly where they are and use technologies to manage that. And all of this should be available through your building, your asset management tools. So there's a lot to be looked there.
Can I answer one more question, Robert?
Yes.
There's one that's come up with regard to cables running through pits. Right. I have a misunderstanding on your pit accessory electrical safety explanation. Is there a safety process defined regarding pits with multiple circuits in or passing through the transformer pit? Your explanation appears to suggest that wherever possible, you isolate all circuits associated with that pit. Surely for safety, all circuits shall be isolated. Yes, if you remember, my actual wording was the ideal situation is that all circuits running through that pit should be isolated. The unfortunate thing about it is this is not always practicably possible. If you think of pits just outside your B center, your substation area, your CCR room, in that area, you may have the circuits for the approach running out, as well as for the area around your stands and on your taxiway. You might want to work on the taxiway circuit further down in another pit. But realistically, because you've got the approach circuits running through the pit as well, and the aircraft are coming in, you have a window where you can close the taxiway down, but you can't close the runway. So the ideal situation, and wherever possible, yes, all circuits should be isolated through that pit. Unfortunately, it doesn't always happen that way. And therefore, with regard to that, you have to make sure that the pit you're working in is safe. You have to make sure you've got the right PPE. You've also got to make sure you've got an accompanying safety person. There should be two of you working when you're working in the pit anyway, minimum of 2 people. So the whole thing about it is, yes, the anonymous attendee who put it in, yes, ideally and realistically, all circuits running through a pit should be isolated. And as I said, that is the ideal situation. Unfortunately, it doesn't always happen that way. I prefer to tell the truth and say how things are than live in a make-believe world.
Right. Looking at with looking at the whole area, there's a lot of potential dangers and risks there. We've looked across now doing 2 webinars on this topic. How do people that are concerned about this get more information and prepare for this? The risk.
What, with regard to working on pits?
Yes.
Yeah, the difficulty you have is that the working on pits has always been regarded as just another part of the job. And speaking with a colleague here earlier on, well, not here, but at the course that I left to come to do this webinar on, he was saying that they're in the process of rewriting their procedures because how it was a few years ago, they don't do it anymore because they've started to realize that there are potential hazards that realistically they hadn't thought of. And the health and safety side of things is now a lot more in your face, and people are more aware of it. So that's the situation. With regard to training, yes, there are training courses available, and perhaps I shouldn't really take this opportunity to advertise, but I will. We've got a 2-day course on pit maintenance available, which can either be done on site if the numbers are adequate, or within our training facilities. There are other organizations that do them, but I'm not going to publicize them.
Okay, Tony, I can forgive you for that. Now, looking at the regulations surrounding the topic of pits and managing them and safety related to them. Carl, you mentioned, and Sir, you may have some input. The FAA has some regulation that pertains to this topic. I've learned over the years that that the FAA has a lot of excellent documentation that has the general principles of which are very relevant internationally. What exactly has the FAA put out on this area?
The FAA has an advisory circular that details requirements for structures on airfields, where you can get the load-bearing requirements for a manhole structure. But if you go back to the OSHA standards, Occupational Safety and Health Administration standards for confined spaces, that can detail work practices that are required if you work in or around a confined space. It'll define the confined space for you, and also give you the safe work practices that are required for compliance. Those are two that I can think of.
Thank you. It just makes me wonder that, given the number of these pits and this very unique nature of our airfield lighting world, that I wonder if there should be some kind of internationally available guidance available for airport operators in relation to this particular specialized area.
Well, a lot of underground utilities still use manholes for power distribution and that type thing. So it would not necessarily just be airfield lighting. It would be all kinds of different electrical distribution. Still use a lot of manholes, especially for the larger cables that you couldn't accommodate in CAN plaza or something.
Okay, so good. Well, we're reaching the end of our allotted time. I'll just look and see if there are any more particular questions. As ever, keep those questions coming, and we will do our best to answer them.
Can I answer one straight away?
Directly.
Can I answer one straight away, which is a nice, easy one? What is the panel's consideration regarding coloured primary cable? My consideration is it looks very pretty. Realistically, you should not use coloured primary cable as an indication of a circuit, for the simple reason, as we said earlier, about adequate spares. If you have got 16 different types of cable being used on an airfield, which isn't an excessive number, 16 different circuits, realistically, you're looking a heck of a lot more. So if you say, right, we'll have a different color or color combination for each circuit, that means that realistically, in order to carry adequate spares, you've got to have 16 500-meter drums of cable. With the best will in the world, if you then have a contractor come on site to replace the length of cable, if he hasn't got the 40 meters of blue and white that he needs, he will use whatever he's got with him. Personally, colored cables are, how can I put it, a recipe for disaster, in my opinion, as the airport gets more and more usage. Because straight off, if they're in the soft, the color tends to change anyway. If they're in the pits and they're exposed to water and general crud, then again they will get different colors. And at the end of the day, when you look in the pit, all you'll see is a series of black and brown cables. You'll still have to hook them out anyway. And the fact you've used a colored cable does not exonerate you from having to prove that you are on the right circuit. So personally, colored cables are they're nice, but not essential.
I've just got another. I see some more messages here, particularly from anonymous attendee. I know who you are. I just worked it out. But
What the shall or should? I know. I think.
Yeah. Thank you for your input. I do appreciate you're keeping us on the straight and narrow here. But yes, as was I think it's implied, we shall, you shall isolate. The word has technical meaning.
To me, with regard to the word isolation, as soon as that word is used, the word should cannot be used with it. Isolation is a shall.
Okay. Thank you for clarifying that, Tony.
The other thing is, if you look underneath that one, there's an official that prohibits working on pits if there is just one technician working on site. The situation realistically is one with regard to lone working capabilities. If you're working in a pit, it may be deemed as being a hazardous area, in which case you cannot work alone in the hazardous area. You need to have an accompanying safety person. Realistically, because of the nature of the beast, and I would always recommend or say that, well, because of the weight of the pit lid to start with, you need to have two people. So therefore, realistically, if you're going to be working in a pit, you need to have two people. If nothing else, it's for the moving and handling requirements and regulations. So that one, you need two people there.
Mike Sparrow, thank you for listening in today. Has asked, is an F900 manhole cover? I don't know if anyone knows their manhole covers that specifically. I'm sure we can find out. But is it still suitable for heavy aircraft, such as soon to be introduced for the Boeing 777X, for example? I don't know if anybody knows that level of detail, but I'm sure we can find out.
The thing about that is we'll have to go through to a manufacturer of an F900 manhole cover, because they'll be the only ones who can give us that information.
Right. We've also got a lot of questions about the different types of lids that you might, the sliding, the hinge lids, and the requirements associated with them. For example, marking the opening area where it comes to actually having a lid. Is that something anyone would like to comment on? Deathly silence.
Right, marking now. Do we have to mark the zone when opening a lid? If you look at the general health and safety requirements and that side of things, what tend to happen is that because of the fact we're going out with vehicles, we've got amber flashing lights and so as what else, where the vehicle is parked so that it is adjacent to the working area. So the working area 9 times out of 10 is identified in that way. Now, a lot of this comes down to because of the time constraints that are placed on technicians working. And one of the things I think everybody who's worked on an airfield will know is that, especially a commercial airfield, is that downtime for the runway is wherever possible a no. So therefore, we work on time constraints. Ideal situation again, it would be lovely to have a marked out area to have be able to put up barriers around it. However, unless it is going to be a long-winded job, we don't generally have the opportunity to do that. The marked area around, what I have seen done is the area around pits treated with a weed killer, so that there is then a flat area, and also seeing the concrete extended around it as well, so that there is a flat area around it, so that people are aware that if that they're approaching a pit, they can see it a lot easier. Yeah, do we have to mark the zone when opening a lid? You don't have to, because it's a restricted access area. But again, with regard to requirements with health and safety, you become the person responsible for any persons in and around that activity area.
Thank you. There's Barry points out that you should have a hard standing adjacent to any manhole, presumably to put the cover on. I don't know, but there may be some requirement there. But I'll leave the final word to Anthony from all the way from sunny or possibly frozen Lethbridge in Canada, a regular contributor to our webinars, who asks, this is for the panel, because I certainly don't know the answer, with all the water in the pits and the potential of ground fault, how concerned should we be with step potential? Is there anyone able to answer that, or should we get back to Anthony?
I think I'd like to get back to him before I make an answer.
Right. Okay. Look, we're out of time now, so we'll get back to that. Obviously, we've created a lot of debate here, but I hope it's stimulated thought. The main thing is that this is a very important issue, and we've talked about some very, very key topics related to that. Local requirements, regulations will vary, internationally, but at the end of the day, obviously, we need to be safe and compliant, and we need to take responsibility for our own safety and the safety. I hope today's presentation, well, I'm sure today's presentation will have stimulated a lot of thought and given you a lot of input to help you in the future. So thank you very much for joining us today as a viewer, and thank you to the panel, and in particular for Tony for putting this presentation together. A lot of time.
Robert, can I butt in?
Go on.
Looking at the number of questions that we've had in the brief time, I'd like to thank the people who have watched this, because it shows that I may not know everything, but I know enough to get people thinking about what they're doing. And if we do that, we'll make it safer for the technicians.
Good. And that's the key thing here. So thank you very much. And so thank you to the panel. Thank you to everyone that's participated in this webinar today, and look forward to the runaway train. And I do stress this is all to do with airports, and we're not branching off into the railroad industry. So thank you. Look forward to that, Carl. Thank you, everybody, and thank you in particular, Tony. Have a lovely month. See you same time, same place. And the date is, can you remind me, Damon?
25th of March.
25th of March, 2 p.m. UK time. Have a lovely day. Bye-bye.
Be safe.
Thanks.
Bye.
Bye.